Now that we've had a chance to talk more about what a confidence interval is and how to find different aspects of it, let's go through the process start to finish. So when we construct a confidence interval, we of course need to make sure that it meets our conditions or assumptions. And we talked about those last week, and that was a good sort of preview for this week. We can never be sure that an assumption is true, but we're going to check conditions and say because of that we feel like an assumption is true. So for proportions, these are what I'm going to be checking. I need my values to be independent. And for that, I'm going to check independence, whether or not one thing is related to the other. Check randomization if my data were collected randomly. And then the 10% condition, which is less than 10% of the population. And then the sample size assumption is the success-fail condition. So we need to make sure that we've got enough values for the central limit theorem to apply to it. So for us to be able to use that, we need to make sure it's large enough. And here are the steps. So we're going to go through and we're going to check our conditions, and then of course we're going to tell what model we're using. And right now for proportions, we're going to be using the normal model, and we should also say the test that we're going to use. So the test I'm going to use here, or interval, is the one proportion z interval. So I'm going to use all of that in that first step. Part 2 is to actually do the work, perform the calculations, construct the interval. So here are some of the values you'll need: your z star, your p hat, which sometimes will be given to you as a decimal, and sometimes you'll be given raw data and you'll have to divide it to find the percent. Your standard error, which is our p hat q hat over n. Your margin of error, which is all of that put together, and then finally your confidence interval. Now the way that I'm going to show you the work is sort of putting all of this together step by step. Now the last thing, of course, is to state our conclusion in context. So I am whatever percent confident that between this percent and this percent of all whatever that I'm testing for, and then whatever that I'm testing for. So of course this makes way more sense with an example, but here's your basic idea. You might screenshot this and remember to use this as you're moving forward. So here's an example, start to finish, of all of the steps. Your local newspaper polls a random sample of 330 voters, that's my N, finding 144 who say that they will vote yes on the upcoming school budget. Now 144 is not p hat, because p hat needs to be a percent or proportion. So instead, a lot of people get confused and say, well, that's a mean, then it's 144. But 144 is not an average. In order to find p hat, I would take 144 and divide it by 330, and that's going to give me a decimal. We'll do that on the next page. Create a 95% confidence interval for the situation. So again, 95%, that's what I'm going to use to find my z star. First thing though, before I do any of that, I have to check my conditions and assumptions, tell what model we're using. So independence, it seems reasonable that people would vote independently of one another. Randomization, it tells us in the question, it's a random sample. 10%, provided there are more than 3,300 eligible voters, 330 is less than 10% of voters. So it really doesn't tell us the size of the school district here. So that's why I sort of covered my basis. And then success fail is n times p hat and n times q hat. Now in this case, I didn't have to take n times p hat because it already told me 144 were the successes, and so the failures would be, of course, 330 minus that. Both of those are at least 10, so I'm covered. Notice again, I have to write the sentence. Because the conditions are satisfied, I can use the normal model, so that's tell me the model, and then to find a one proportion z interval. So this is the test that we're using. So the model and the test, all of that goes in step 1. Now that I have checked my conditions and I've said, yes, I can use it, now I'm going to perform my calculations and construct the interval. Now, depending on the way that the question is set up, quite often in StatCrunch, they'll have you find kind of each part separately. So they'll say, okay, find p hat, and then you'll divide those two to find the 0.436. Or they'll say, find Z star, and then of course you'll use technology to find that it's 1.96, or they'll say find the standard error, and the standard error is all of this square root. If you're just doing the confidence interval, I just like to go straight for it and just put it all together. So the p hat is what I would get when I take 144 divided by 330. My Z star is found because it's a 95% confidence interval using technology. Here is the 0.436. Now, where did that come from? That's because when I took this value divided by this value, I got 0.436. Don't round this off to 2 places. Go to 3 or 4 places just to be safe. So 0.436 here, 1 minus that here, so that's p hat, q hat, n is 330. And then instead of finding this and rounding it and then taking it times 1.96, I just did all of that work in my calculator. So I have 0.436 plus or minus 0.053. So where did these come from? I took 0.436 minus 0.053, and that's this value. And then I did the exact same thing, but I added it instead. Now, what's important to understand is this is an interval, just like in any mathematical interval, which always goes least to greatest. So you will get this wrong if you add first and put that number first. So if I put 0.489 comma 0.383, that would be wrong because it should go from least to greatest just like a number line does. So this is my interval, and of course I would write it exactly like this in part 2. In part 3, I'm going to then find the conclusion. And the conclusion in context, notice I'm not going to write them as decimals, but as percents instead. So I'm 95% confident that between 38.3% and 48.9% of voters will vote yes in the upcoming budget. And again, that's based on my sample. So before I have you try that process on your own, I want to make sure that we understand confidence intervals. So here are a few questions I'd like you to ponder, to think over on your own, on whether or not my interval would be wider or narrower. So here's the first one. What if we wanted to be 90% confident instead of 95% confident? Would that interval be wider or narrower? Well, we know 95% confident. 90% confident would mean that it's a little bit skinnier because now there's more of a chance of stuff happening on the outside. So that should be a narrower. Our interval would be narrow because we're less confident. Next one, what if we wanted to reduce the margin of error? So again, the margin of error is how far out from p hat do I go? That's the margin of error. So if I'm reducing that, I'm bringing that from here, say, to here, then of course that would mean our interval is narrower because I'm reducing the distance that I'm going from p hat. Now, what if I sampled more than 330 people? So what if I increased n? Well, before we answer this one, let's think about how we find our margin of error. So we find our margin of error by taking z star and then p hat, q hat over n. So whatever 330 is, I'm dividing by that. So if I increase the number that I'm dividing by, this number gets smaller, which means our margin of error is going to get smaller, which of course means narrower. So here's one for you to try on your own. So I would like you to try this question all the way through, so all 3 parts, and then press play to check your work. So first we would check the conditions. And the conditions are independence, random, 10%, and success fail. Now, independence, we know that whether or not one person responds to the medication shouldn't have an influence on another person's response to the medication. Random, it doesn't say that it's random, but we did study experiments in this class, and we knew that in order to develop an experiment that was effective, we should have random assignment of each of the treatments. So we're going to assume, because it's part of an experiment, that they are random. 10% condition, kind of a tough one. We don't really know how big this medical test is, but because we're testing medication and not patients, we don't really care about the 10% condition because we don't care if it's representative of the population. We want to check people who obviously have a specific disease and whether or not they're being helped by this new medication. Success fail, I'm going to take n, which is 53, times p hat, which is of course my 27%, 0.27, And then Q hat would be 1 minus that, which is 0.73. So I have 14 and 39. They're both at least 10, so the sample size is large enough. And then again, notice since the conditions are satisfied, I will use the normal model to find a 1 proportion Z interval. Calculations. So now I want to actually make the Z interval. So I'm going to start with my 0.27. And plus or minus, we're looking for 95% confidence, so use that technology to find the 1.96. My P hat is 0.27. My Q hat is 0.73. And my N is 53. So I'm going to do all of those calculations and find 0.15 and 0.39. So that's the calculations portion of it. And then, of course, my conclusion. I'm 95% confident that between 15% and 39% of patients will improve after using the new medication.